Hello everyone. Today we are again together. Jeff Tantsura with me, Tony P with me, and we will discuss about beer. We will not drink beer, but we will discuss this technical beer. Bit indexed explicit replication, hard to say, but you will see, you will enjoy a lot this very promising protocol we have here. And before further ado, welcome guys. Welcome Tony, welcome Jeff.
Hey, Aaron. Normally I drink beer during beer presentations, but I ran out today, and it's kind of early in the morning, so
Early in
don't
the
give me
morning.
idea.
Okay. So, Tony, for the audience who may not know you, can you briefly introduce, please, yourself?
Yeah, I have been around routing protocols, networking technologies for, well, let's count, yeah, 30 years almost, and involved in a lot of mischief, mostly around routing. Beer is one of the things that I helped bringing up, chairing the working group. Otherwise, my paycheck is picked up by Juniper. I'm a DE there, doing all kind of events, interesting stuff, still writing a lot of code. So thanks for having me here. It will be a good discussion.
I'm great to hear you. Jeff?
So, Jeff, I've been around with Tony for quite some time. My dog beaten him twice. So another BGP developer beaten only one.
Okay.
Yes.
By the way, guys, we also recorded and shared really good and long and very explanatory video, three of us before on the channel. You can see it's Rift routing in Fed trees. I definitely recommend you to look at that one as well if you are dealing with the routing, if you are trying to understand the cloud topology, the data center routing, and many other advanced routing stuff. Definitely you should watch that one as well. By the way, I should say that Tony P is the author of that, and I mean inventor of the protocol. So he is quite involved with the BIER as well. BIER, we have an RFC for BIER, and he was of course actively participating for that one as well, and one of the top guy which we could talk about BIER. And you will enjoy a lot if you are especially again trying to understand the multicast routing, large scale multicast design, so on and so forth, and probably a couple other things as well. This is this session for you. Let's jump in. Yeah, let's start, Tony.
Oh, up to me. Yeah, so first, so what is BIER? BIER is a radically different way to do multicast, and it's actually not even IP, right? It's a technology that is actually defining how to build a switching fabric, just like MPLS. It's a 2.5, so layer 2.5, and it gives you basically a switching fabric which is multicast capable. So the idea, I don't know, came up probably 4 or 5 years ago. Jeff actually put me together with the original guys who had like half-baked thoughts about how to do it. And then we started to roll it. It is, yes, RFCs are there. It is actually a proposed standard. So it's a standards working group. We have a lot of advanced topics rolling right now, but the core thing, so the signaling and how you actually build a data plane is cooked, yes. And we have multiple vendors supporting chips. Yes, that's the state where we are.
Okay.
We should start to talk about what it is. Huh?
Let me make them more excited, those audience at the moment when they watch. Basically, we were also discussing this point, and throughout the presentation we will talk about it. For the segment routing, from the scalability aspect, I made this comment before. What about segment routing is doing for the unicast routing from the scalability aspect, like don't keep the state in the network, etc., but in the packet header. BIER is doing for the multicast. That's why scalability comes in the first place. But this should be.
Let's make it a little bit more differentiated. So the way BIER, so multicast was scaling very, very poorly, right? So we can talk about the current state of multicast, but basically you had the SG, star G, all this state leaking into the core, right? So that allowed only for very poor scalability. You scaled with the number of VPNs, number of groups, right? So the scalability was very poor. BIER takes MuLticast and makes it something like the longest prefix match on Unicast. Because think about Unicast, how to do scale Unicast. We squeezed out all the addressing to the edges, right? So because we don't carry host routes in the core, but that's basically what MuLticast was doing. And BIER pretty much squeezed that out. So in the core, you only have something like a longest prefix match to replicate MuLticast, right? But in a sense, it is not segment routing. The packet does not carry state that determines the path. The packet just carries the addressing where the stuff is supposed to go to. So the segment routing comparison goes only so far. Yes, we squeezed out a lot of state, but we didn't push the routing decision to the edge like segment routing is doing, where you have to put label stack.
Yeah.
We still
when I said that, actually, we also discussed this one on the LinkedIn, one of the posts. I remember when I said that, you also commented. But my point is just for scalability aspect. So because we will also talk about the BIER, how it brings more scalability compared to traditional multicast solutions. From only that aspect I said, probably you got my point now. Just from the
So to put it simple, there is no per flow state in the network, right? So you could scale much higher number of entries.
Right, and there is no tree building protocol in a sense either. Right?
Yeah. Also,
where it also is kind of similar to segment routing, if you really want to track it there, we use IGPS signaling.
We use IGPS signaling also when you have segment routing. For, let's say, MPLS VPN use case, you remove the requirement of LDP, RSVP, etc. with the segment routing. When you have, let's say, BIER, this is the whole idea, guys. If you want to just get what BIER is doing, you should understand this. When you have BIER with the IGP signaling, basically those, we will talk about some bits, those bits will be carried within the IGP message, IGP control plane. OSPF, ISS will do that. And with this, basically, we are removing the requirement of LDP, PIM, for example. For multicast, we don't need PIM. We don't need MLDP anymore. Point-to-multipoint LSPs with RSVP anymore. This is the important point. When I understood this one, and by the way, probably this is the level that I understand, not more. I will learn from you. So, but this is really showing that this is cool because protocol elimination. Less protocol to deal with.
Well, I mean, as always, the price you pay is a more fragile IGP, right? And I mean, let's not forget that the IGPs were resisting any kind of additions for 20 years very successfully, just because of the fragility, right? So all the signaling has been always pushed out of IGPs. And I was probably one of my roles in the BIER staff was to actually go to the IGP people and nefariously convince them that it may be a good idea. So yeah, we sneaked basically the BIER control plane into IGP. We put it on a separate one, but the BIER IGP control plane is actually extremely lightweight. So it would be kind of an overkill to actually build a separate control plane. But in a sense, you could. You can also run BIER with an overlay signaling protocol. People do stuff like that. Right.
Why you are saying when we add extra, let's say TLVs, etc. I think you are talking about when we add those. Why you are saying it becomes more fragile? Is it because fate sharing, like doing more than one job for the?
One of the things. The other thing is, of course, first, very mundane reason. Your parsers and your encoders start to become more complex. And on today's IGPs, and that's where, for example, Rift is highly differentiated. Observe the discussion now we're having on the mailing list about the decoding, where everything is model-based in Rift. Like, well, you don't decode packets byte by byte. Today, all the IGPs are hand-stripped, very artisanal activity. People make mistakes, especially on complex encodings. And one little TLV that runs haywire in BIER, in SR, you name it, can melt down your whole IGP. And this is one of the, most overvalued experiences in life when your whole IGP goes down, as you know, right?
Yeah. But to show you what we are trying to do in ATF right now, a few years ago we published RFC 7684 that defined TLV encoding for SPF-v2. So opaque LSAs now could be encoded in a much easier way, much more extendable, and we use it for segment routing. We are about to publish 2 RFCs on decoupling IGP signaling from basic traffic engineering. So before, if you want to do any opaque signaling, you have to use traffic engineering extensions. Now we've got almost 2 RFCs on SS and SPF to have new set of attributes you could signal without enabling traffic engineering.
Like
this very important step in decoupling this.
Those white metric, etc. in ISAS, TLV, 22135, etc.
Yes.
For example, you want to use something for LFA, but not for traffic engineering. Today, you have to do this anyway, same way, right? Here, you will have new set of attributes to completely decouple it, not to create all the complexity traditionally associated with traffic engineering.
Yeah, but now imagine, I mean, look at the encodings today. Someone said doing ISIs today is a modern day alchemy, right? Like turning stone into gold, right? Like very arcane art. And now you have people, and a lot of people are retiring. People who specify the stuff have been in the business for 30 years, right? So they're out. So you get someone in who may not even comprehend the complexity. And those parsers are hellishly expensive, so it takes one line of code to melt down your IGP. So, that's the price you pay. The other price you pay is, and that can be partially solved by decoupling Jeff talked about, but IGPs are basically broadcasts, right? So you scope your what you call it?
Push-based.
Blast radius is your whole network, well, area. Not much better, right? So whoever changes an opinion on anything, everybody shakes. That includes CPU resources, flooding the stuff, highly coupled system with huge blast radius tend to be fragile, right? So there's no free lunch, but it's popular, and it's arguable whether removing something, a big complex block like LDP, and put it into some IGP signaling is not saving you, good amount of headache. And people seem to be thinking that, but it will just take a couple of serious meltdowns, and the pendulum may swing just the other way, right? We build layering for a reason, right? And then we layer too much, and then things starts to get slow because indirections always cost.
Like having IPv4 and IPv6, then having any problem with the IPv6, instead of bringing happy eyeballs, just turn off IPv6. So because of problems.
So to give you an example, we all hate LDP IGP sync, right? Buggy stuff, nasty stuff, right? So in segment routing, we distribute both through the same protocol, but now you've got all the interaction within the protocol because you still have your label base, your prefix base, and they interact with each other. So while it might be invisible from outside perspective, inside, code much more complex, there's many more states, and it could break inside as much as it could break outside before.
Wow,
So
this one is very, very critical actually to talk. Now we will start discussing BIER, but last point let me make. Usually when you discuss with the people who, for example, LDP versus RSVP, one of the points SR guys will to do, we are eliminating LDP, so IGP LDP surface, those interaction like LDP IGP synchronization is not an issue, they will say. But on the other sides, Tony and Jeff, their points also, protocol will be more complex. Within the protocol, still there will be some interaction. Not now, we have multiple protocols to interact with, but within the protocol, still there will be interaction, and the protocol code will be more complex you need to deal with. So there is, and Tony just said there is no free lunch, so that's the idea. You are maybe simplifying by removing one protocol there, but you are maybe making code more complex, so you need to keep in mind. Excellent, so let's start. What we will talk about here? Better IP multicast.
Yeah, so better IP multicast. So basically, we set out, we looked where multicast is not deployed in the core very widely, and we thought how to build a better technology. And I think the original thinking was just to deal with IP multicast. And I was one of the people or maybe Eric Rosen and me, were pushing to the direction of guys, because we knew from start on we'll need a new silicon. A new silicon is being done. I mean, think MPLS 15 years, right? This is something like MPLS. You really have to show people a lot of long-term benefit to justify the silicon. And there is a lot of other considerations when you change silicon. For example, you cannot make it too rigid because for two reasons. First, the requirements will change, right? New applications will come. Second, vendor need to differentiate. If it's just a vanilla thing, everyone implements the same way. No one can basically invent something they can charge a premium. So you want the technology which, in one hand, is flexible to take up new requirements, but also flexible enough it can be implemented in different ways, in different dimensions, going either for speed or for scale or something like that, right? So Eric Rosen needs to stretch the concept a little bit, and what it really is a 2.5 switching fabric. So just forget IP. You could literally use that. And here's a little dirty secret. Lots of vendors were using this kind of technology on the internal router fabrics in chassis. Okay?
They are using.
Sorry?
They are using.
Yes. I mean, some flavor of this kind of technology, which is, basically took it to the size of, core networks, right? Okay. So, I have some slides, and we can talk about what was going on in the MuLticast today. I don't know whether we trust or whether all your listeners are pretty familiar what the state was.
No, let's talk about it, of course. Let's talk about it.
Right. So what we found is that, look, it was even hard to offer some. So L3 VPN were a runaway success. I mean, the amount of money that has been made with L3 VPN is absolutely sensational. There was something to the tune of $1 trillion plus over the lifetime of the technology. And we looked at MVPN, and MVPN is a very limited technology in terms of commercial deployment. It's a premium offering on a very small scale. And when you look into details, why? Because it's really just scaled with the number of VPNs. That the VPNs leak into the core. As you pin trees, as you start G state, whatever, you look at your forwarding state, your silicon has to soak up, your whole core has to soak up the whole VPN. But that doesn't scale. The core router silicon will always be very expensive, right? So then you had PIM on top, which was based on all these soft state ideas. And when you visualize PIM with something like, well, they have been bought now by Sienna, packet design, you will see that PIM never converges. Well, BGP never converges, so it's a good thing, right? But there is a point at which never converging becomes onerous. It stops to being, an accepted good thing, right? Then what you needed on top was still signaling, right? You have point-to-multipoint RSVP, MLDP, LSPs, and so on. And you had ASN, SSN, right? So you had this whole zoo. I mean, it's a wonderfully written draft explaining the technology with selective and inclusive and bidirectional, right? The whole zoo, right? And every technology we're giving you a piece. Here we have some ASN, here we have some SSN. This tunnel is inclusive, this tunnel is selective,
I mean,
multiple tunnels.
Tony, we have, I think, around 17, how many? More than 15 profile, they call it, MuLticast profile. It's so much to remember. Okay, they are looking for different options. I mean, in general, the characteristics, but lots of profile, lots of complexity for me, for everyone, I think. And another thing is state. But for the state, I want to ask something. Okay, when we do like a Rosen GRE, so when we have the PIM, let's say, in our core, the forwarding table will keep the customer PIM information, customer state in the network, in the core network. But when we have MLDP or RSVP, point-to-multipoint LSP, do we still have the state in the core?
Well, you set up the tunnels. You keep up the tunnel state. Don't forget.
Yeah.
You have a per flow state, right? Every tunnel keeps up the state. So MLDP didn't scale. So they were talking about hierarchical MLDP, right? So that stuff, this is all very, very significant complexity. Lots of per flow state in the core, right? Then after everything has been done, you still have the problem of the core placement, right? But it's still unsolved, right? It's actually a completely separate problem we can talk long about, and CBT and so on, everything long forgotten. So when you look at like why did the multicast scale? Because they violated the prime paradigm of the internet that the edge state never leaks into the core.
So,
Be it addressing or flow state or stuff like that. The core is in a state, in a way, state free, largely.
yeah. So
Okay.
keep the complexity and state at the edge.
Right. I mean, that was pretty much Postel, right? I mean, this is what really scaled up the internet if you look at it. And multicast was piloting it in the current state. So we basically started to think what is needed, and what is needed is a switching fabric, just like MPLS, that is multicast capable. And we started to think how to build something like that. Okay. And of course, there was a lot of failures. So, well, we just kind of listed requirements, all the stuff we would like to have, right? And so first we wanted the convergence and speed of Unicast. That was one of the reasons why we put it into IGPs. There was more reasons that just, oh, we want to save ourselves a separate protocol. You will start to see that putting into IGP gave us a lot of very interesting properties at the end. And we wanted the state compression. And then basically think about longest prefix lookup. Something like this for multicast, right? Because ultimately the core holds some state, otherwise it would be worthless, right? But the state is highly compressed. Those are the LPMs. That's why we can have 100,000 entries and route the whole world. So we wanted something like that for multicast. And then we basically wanted a point to multipoint, multipoint to multipoint, selective, inclusive, all in the same technology. Let's try to simplify the zoo, right? What I want is a fabric where I address a bunch of people and it magically shows up there. And it goes both ways. And every packet I can address a different set of people because my set of people may change. And BIER a lot of people start to look at the technology because there's a lot of interesting properties. Now imagine that you have a fabric where with every packet you can address different set of people. Now that doesn't have to be a network. Think about RAID striping. When you write sectors to disk on a RAID, that's precisely what you do.
Okay.
So you need precisely the same technology. Right?
Yeah, but for me to understand, couple points up to this point, like convergence at speed and stability of Unicast. When you say that, I think because when we have multicast, we cannot have fast reroute unless we are not doing live type of multicast or implementing multicast only FRR, MO-FRR type of things, because tree needs to be rebuilt if you don't have live.
Does that, right? So if you want a completely disjoint, so because BIER runs directly on Unicast, it really does not. BIER can build any kind of tree, but assume the simple one that it just follows SPF. What falls out is actually that we can use all the FRR. We can use all the ECMP. So all of a sudden we have multicast that can actually go ECMP, which is kind of a weird idea, but it works. Or it can use Unicast FRR if that's the protection good enough for you. It works like a charm.
Yeah, and also important thing is there, when you do that, you don't have to deal with the RPF as well. And you can, as you said, you can take the advantage of IP FRR and many mechanisms there, LFA, remote LFA, all of them can work on top of that.
So RPF is actually even more subtle. That BIER, even if Unicast loops up on you, it will not form loops. But that will go too far to explain that. So the math is actually deceptively simple. And I know of multiple PhDs who tried to work it out and never figure. And actually, that's mostly ICE from Cisco, who figured the math out. And I actually had 2 PhD students check it on his original proposal because I couldn't believe that it actually works. But the math works out. When you flip off the bits while you're forwarding BIER, what you end up with is with a loop-free technology, which basically means that you can loop up once back to the place you came from, and then the loop stops. That is a beautiful property.
Yeah, interesting.
Okay?
In fact,
especially for multicast. Multicast is a virus. You know, everything that puts one packet in your network and you can have 2 coming out, that's a virus. It doesn't matter what it's called. So if you have a virus,
if you look at fast route with MLDP, for example, while you use same computation, you still need additional means to synchronize the states at PLR, right? With BIER, there's no need as such. If there's topology change, you just follow it. That's all you do. There's no need to resynchronize states between PLR and merging points.
So yeah, for this one, little bit you need to probably understand the FRR terminology, guys. Let me just in a 30 seconds let me explain the PLR, point of local repair. So when the, let's say somehow link or node fails, the first device which is attached to the failure point is called PLR, which will divert the traffic to the alternate path, and then that let's say LSP, and that LSP will join to the protection, the primary LSP at some point, maybe next stop router, maybe next stop router. We call it MP merge point. So now with the MLDP, when you do the FRR on top of that, what Jeff is saying, between PLR and merge point, we need to synchronize the states. Basically, they need to know, for example, RSVP, there is a session object that merge point is carrying within the RSVP messages to the PLR, so PLR knows that which label it was expecting before the failure, etc. This is a little bit advanced topic, I could say. So if you don't even understand this one, you can...
7715 or 7715 that describe what needs to be done for MLDP to support node protection. It's really easy reading, and I would advise to read it if you want to understand semantics when you need to do something like FRR in MLDP2.
Okay.
So 7715.
7715, guys, if you are interested to understand this terminology as well as how MLDP with the node protection, one of those local protection mechanisms, there is link protection as well, so you can have a look at those if you are interested. So good. So with the BIER, we don't have to synchronize any states, you are saying now.
Correct. It's a fully distributed computation. Now, you cut on two interesting ideas, that I'll get to. But the one idea, which is vastly underestimated in IP, it starts to wake up. But let's put it that way. This technology has been pushed by people. One of the industry who was pushing this technology very strongly was someone who had a lot of money but needed very strict OAM. So one of the things that we put into BIER is basically a native OAM. Because when multicast fails, it's hell to debug. So the technology underneath gives you a full possibility to figure out what failed. Not only that, to measure fairness of delivery.
Mm-hmm. OAM, strong OAM, you wanted.
Yeah. So that has been built from bottom up to understand jitter, fairness of delivery, failure detection, these kind of things. But the last thing that you said, like, okay, so multicast protection at the end, you really need live. So I said, well, IGP will give you FRR. That's kind of cute, but that's for live, that's not good enough, right? Live. If you really think about live, so let's forget the last PE. Let's assume you are willing to have one failure on the same PE. But what you really want is two strings that go completely to disjoint paths in the network, right? They basically share, they have no fake sharing whatsoever. And BIER allows you to do something like that by the following concept. That does not only apply to that. BIER allows you to have subdomains, which you can think about like having multiple instantiation of the same fabric on the same physical substrate. So like running two different MPLSs at the same time on your network. So BIER supports it natively. And that is actually coupled with IGP multi-topology. So you can very easily separate your IGP, or not separate, run basically two IGP planes and determine which plane runs where, and put two different BIERs up and route your multicast two different ways, having a guarantee that you have disjointness. And in case of failures, one guy can back up the other if there's no disjointness possible. That's kind of pretty advanced. Why this concept is also helpful, because now think you're running this multicast service and you want to offer different quality, right? You don't want to cram everyone to the same fabric. You want to be able to differentiate what is, how much resources you give to what type of multicast service. You can instantiate BIER multiple times.
So I see this one use case in the financial networks which deploy dual plane design.
Sorry, come again, Orhan?
In the financial networks which they prefer dual plane, so different topologies. Sometimes we are seeing different even vendors, etc., in different planes, disjoint paths, disjoint planes.
Yes.
So and multicast also for them makes sense as well. Most of them they already do. So yeah, I see that use case.
Yeah. So that's also baked into the. I mean, I'm a big fan of multi-topology. I mean, I think I talked about this 15 years ago, right? When multiple GISIs have been done, that people are becoming more and more aware for a lot of for a lot of use cases of call it what you want, call it whatever colors now, or people. Well, I don't want to quote the 1925, like same idea, repackaged,
Yeah.
whatever, right? But this concept of instantiating multiple planes and being able to either throw them on different parts of physical topology or even run on the same physical topology is a very powerful concept that always finds a lot of use cases.
I think
right?
SR says flex algo.
Flex algo, right? So that's another flavor of the stuff. But basically, what you want is, we know what we talk about.
Yep.
So that's baked into BIER from start on. And we couple the stuff with multi-topology. It wasn't actually even me. The other inventors kind of coupled with multi-topology, which is a fine thing when you signal IG. So that's kind of the nucleus. And so how do you go about it? Well, simple. You put a set of receivers on the packet, right? That's what you do. And internally, in the core, you just know which receiver where to replicate to. And guess what? That has been already tried in the 90s. IBM, Nancy Feldman, long forgotten effort. But they were always trying to cram a whole IP address as a destination on the packet, right? So in a sense, they invented SR.
To add to that, in Red Dot Networks, we filed first patent on SR in 2004.
Right.
It's not very new technology.
So, I think you were also working at some point there, right? In Ericsson.
And Tony as well. This is where we met.
Okay,
Yeah,
I didn't know that. I didn't know that.
Yeah, but I was. I actually Redback bought up a startup that I was one of the early people that were founding. That's where actually the whole Redback IP stack comes from. Actually, it's from this startup because Redback threw the whole thing away when they bought us. A long time, didn't happen anyway. Anyway, so now the problem is that if you start to scale multicast and you have thousands of receivers, even hundreds of receivers, and the amount of information just kills you, right? Just too much stuff.
Yeah.
So we invented the microSID. Of course, I'm just making jokes now here, right? Like, little jokes. We realized that the smallest microSID is 1 bit, right? And it's here. What you basically do is you indicate with a single bit whether you address receiver or not. So that's what you put on the packet, on the encaps. You put a bit mask, and the bit mask signifies a set of receivers. That's really what it is.
So instead, this is very critical because we cannot see this one in any other resource. In fact, let's a little bit for me to understand more. Let's understand. So first idea was putting each receiver on each packet. At the moment, how we are identifying? I mean, the current BIER, what I know is we have bit mask, and each bit mask is defining a receiver. So if I will push the same multicast traffic to multiple receiver, let's say 30 different receiver, I need to set those bit mask position in the packet and then push it. So the difference from the state point of view, I am trying to understand. What would be the difference if you would follow the first idea, which is putting the receiver on each packet? I think it was not the bit mask wise. Was it the IP destination wise?
Yeah, correct. Your packet just blows out. It's like the SR-SID problems, right? To try to put 30 or 40 IP addresses, 30, 40 IPv6 addresses. Your header is basically the only thing you carry around.
Just a second. This is important because I cannot still understand why I cannot do then. Let's say if I have 30 different receiver, if I can summarize this one in single entry or maybe couple, just 2 entries, is it fine?
Yeah, but then you basically just invented the multicast group, didn't you? But then you somehow have to signal all the stuff what this one thing means, right?
So this,
and then pretty soon you basically have a multicast group. That's what you're doing.
This is very critical.
Multicast group represents group of receivers, right?
Yeah.
It's not a single. It could be single, could be thousands of people. That's what Tony is saying.
Yeah.
You don't have a concept of a group.
That is clear. That is clear for me.
That's the destination set, and it can be per packet.
That is clear for me, but how this Bitmask, because the first time I am trying to compare the Bitmask versus IP Unicast destinations and summarizing them. Let's say summarizing IP destinations versus Bitmask for the efficient multicast. I mean, because...
So think like this. Why this Bitmask has a good advantage? So let's say you just have 32 of those things you want to address. It's very important. BIER scales because you don't have to address every router in the middle. It doesn't need the bit. You only address the receivers with the bits. So let's say you have a huge core and you have 4,000 bits. Well, the 4,000 bits are enough for a really big edge. You only address the PEs, right? It's a very key concept. BIER doesn't force you to have a bit reserved for something in the middle. They just blindly forward. Okay, so the first thing. The second thing, now think you have 32 bits, and you want to address every possible combination, how you can set those 32 bits. That is a lot of multicast groups. Really, a lot. With BIER, you don't have any of this information.
You don't need a group, in fact.
No, you don't need a group. You set on every packet the set of bits you want to push the packet to, and you can choose per packet a different set of receivers.
Oh, there was one design last year. I think I was involved. The guys, they had around 2,000 sites, 1,900. Let's say 2,000 sites, and they were carrying. The transport was satellite, but it could be anything anyway. Over the satellite, they were carrying some. This is hypermarket chain company, and they were carrying multicast on top of that satellite to basically send some radio information, like broadcasting some discounts for some products, okay, to the, and then they were using multicast and pushing the same feed from the head end 2000 location. Now, if generally when I think about BIER, it comes to my mind immediately because Bitmask in this case will be 2000 long, and I think the problem starts from there, that how many bits we can address in a forwarding.
Correct. So now we can start to break it down how we address that, but that becomes more, I would say, tactical. Now we're talking like the strategic high picture, right? Because look, if you have always the same 2,000 sites, well, by all means, I mean, just have one multicast group, you're done, right? But if you deploy MVPN, that's not what you have, because every customer subscribes on a different set of PEs. So then you end up in exactly this hell, like, will you have a per customer selective tunnel? Or will you have an inclusive and kill your network and then throw 90% of the traffic on the edges away? Because you basically broadcast. Got it? So if you have a single multicast group, by all means, you have 3 multicast group, by all means, I mean, well, deal with PIM. You have 3 entries in your network, like who cares? Right? You have a star G, you have 3 of them. G, by all means, I mean, if you have a great business making money, super, but you don't have a scale problem. Right?
Okay. Now we could say this, like if you are dealing with the 5, 10, 20 routers, don't deal generally what we say, don't deal with the multi-area OSPF design, multi-level ASS design. And if you have just if you have just few entries, you don't have to deal with the BIER, you don't have to, learn BIER, etc., or deploy the BIER there.
But like any very fundamental, well thought out, orthogonal, powerful technology, BIER metastasizes into very weird corners. So one of the places where BIER is being, looked very closely at is HomeNet. Because now think, you need multicast on your HomeNet. Now, by all means, you want to run PIM in your home, even with 3 routers? Right, exactly, right? So BIER is so simple, and actually has been put on Babel, which is right now, making very big inroads into something, call it HomeNet or not. I mean, HomeNet was a framework they standardized, but ultimately you have a home network.
Actually, I will
Babel,
do the session with the Julius, I think. So on Babel, we will talk.
Perfect.
Yeah.
So otherwise I would have hooked you up, right? So BIER was already put into Babel. It's very easy to put into Babel. Ripple is a very interesting discussion what they did with BIER. I'm not following it too closely. They actually have very big restriction on Bitmask. So they actually are putting Bloom filters into RPO. It's kind of too mathematical, forget. But BIER is really simple to implement, and because it's a hop-by-hop 2.5 technology, you don't even have to process it on the ASIC. We're actually standardizing carrying BIER over native v6 as next protocol. So you just go link local to link local, push it up to the slow path, process it, push it out link local to link local, so you don't even need any chip support. And then
will it be performance-wise? What will happen?
What you need in HomeNet?
Okay.
Are you doing like million of packets multicast? Probably not. And if you do, somebody will put it on the silicon.
But same solution wouldn't work for the core network in the self-provider, for example.
Well, so correct. You could, yes. You could, right? You could, yes. So here we are, right? That's the stuff we all desired, and there was this big per receiver idea, and of course we stood in front of like, okay, we have 4,000, we didn't have solved anything, but then a couple of smart people started to, I almost go over a couple of smart people comes from being Polish and talking with 2 hands and living in Italy for a long time. So a couple of smart people started to look at that and solve this technical problem. It becomes very technical. How does it work in detail? We can talk about the stuff, but that is like the strategic picture. That's what we put together. This technology that satisfies all of the stuff that seemed pretty impossible at the beginning to like hook up in a single technology. Okay? And then of course some multicast guy said, we won. Unicast will be a special case of multicast.
By the way, this is interesting. BIER forwarding based on Unicast, and we don't introduce any multicast protocol here, but we are achieving multicast. And in fact, this is not also Ingress replication. So it's not like Ingress replication Unicast, but it is truly multicast by doing Unicast, following Unicast control plane also. Interesting.
So there are 2 sides to it, right? One is core signaling, another one is host signaling. So the first goal was to deliver or actually enhance core signaling. On the edge, you could still use IGMP or MLD to signal joins and then have a point where you translate IGMP joins into BIER.
Sure, even for the service.
More helpful is to think that IP multicast is one possible overlay technology you can run on BIER, using BIER as a fabric.
Whatever was possible before BIER still is possible. If you can signal the customer information on top of the core network via BGP or PIM, you can still use it. But we are basically simplifying and making more scalable transport network for the multicast.
Well, so if you're deep into multicast and you all do all these different tunneling technologies, BIER is nothing else than the multi-point to multi-point, inclusive and selective tunnel at the same time. And if, for example, look at our NDPN implementation, BIER just shows up like yet another tunnel you can plug under our MDPN because, well, sorry, the vendor speak. Our MDPN is completely decoupled from what kind of transport, multicast transport runs over, right? So there's this beautiful RFC that has been written by Eric and Ice and a bunch of other people that really kind of explained what are the different properties of a multicast tunnel you can have as a technology. And we are really just a multi-point to multi-point, selective and inclusive at the same time. So you can run multiple selectives, like I explained, multiple BIER subdomain, which will give you multiple tunnels. And you can make some of them selective, you can run it as inclusive. You can do all kind of weird stuff, but it's really another multicast tunneling technology, the way the overlay system.
Yeah.
Which makes for very simple implementation, okay? So if you want a little bit of a technical picture, then this is a good picture. It basically explains what happens in a BIER router without explaining any excessive details, right? And I'm talking here just about MPLS encapsulation, which is kind of the simplest to comprehend. We also have native Ether and V6 and so on, but this is very easy to explain. So now think about BIER, just like SR is kind of, so SR MPLS for me is MPLS with a funky lookup behind it. Because traditional MPLS is basically, here's a label, you only allow pop, swap, 3 operations. SR is nothing else but, oh, I can do an IP lookup behind it. And BIER is something really funny. It basically says, oh, I got a label. There's this really funky operation behind it that does multicast. You can think about the stuff that way, right? So if you go from the left on the red packet, you get a packet incoming, which actually has an MPLS label on it. And you can put it into an MPLS label stack, and the BIER label will be, of course, the bottom of stack, right? That will be the last label, because behind that is really a BIER packet with a BIER mask. So what the label tells you is which plane are you on? So that's the first thing, right? So are you on the red, on the green, or the blue plane? But then also now you have a 4,000 bit destination mask. And you go, I don't want to carry 4,000 bits. So you can chop it up into 4 1,000 bits and give each one a label. So the label, in a sense, tells me which part of the addressing Bitmask do I talk about. And there are, of course, trade-offs, because if you have a 4,000 bits and you set 4 bits and each of them is in a different part, then you will end up sending 4 copies.
Okay, just a second. Now, this label,
Yeah.
Tony, here, the label which I see there in the red packet is the, so let's say we are doing MVPN with BIER, so is this transport label, not the VPN label, obviously, or this is BIER label, right?
This is purely for BIER purposes, a BIER context. So
overlay is transparent. You don't look into overlay labels in general when you forward traffic, right? It's only destination node that does it.
Okay, just a second then. Normally, when we have just without this BIER solution, when we do the Unicast MPLS VPN, we have outer label for transport and inner label for service. So where is the location of this? Between the outer label and the VPN label, or?
It's on top.
Well, the top, which is the bottom of
the very top. Okay. The outer label, we call it. It's also transport label, we can call it.
Yes, this is the transport label, because it identifies the transport, and the transport is BIER. That's probably least confusing to talk about. Yes, it's a transport label.
When we have this,
from service perspective, label is still downstream allocated and signaled through BGP or any other control plane to the upstream.
So you can also think about that stuff. This is an unsolicited upstream allocated label.
Yeah.
Correct me, Jeff.
But then in a classical IP MPLS network, if I am doing MVPN with BIER, I will end up with 3 labels, right?
Why 3?
Because now BIER label, let's say I am doing for the Unicast signaling also LDP second label, and BGP label.
No, there is no LDP.
There's no LDP. NVPN, this is the transport. This is the multicast tunnel. There is no LDP, there is no PIM, there's nothing else.
Okay, PIM is obviously not there, but then
VPN on top gives you overlay.
Okay, for MVPN I will have 2 labels, one BIER, another is the service label, and for Unicast.
IGMP would work over that. That probably explains it very easily.
Okay.
So imagine you have this thing in the middle, which is BIER capable. So you have 4 bits available, right? And the way IGMP would work on that is you join a star comma G, and you run on this BIER fabric. So basically what you do is you send this IGMP join to everyone except yourself. That's the 1110, right? Mm-hmm. So that's the rack broadcast. So BIER now is this inclusive tunnel. So everybody gets hit with the stuff, and I understand the guy with the bit 0001 joined the G. Okay? The blue guy does the same, that's the step 2. So he sends also this inclusive to everyone, but he's of course another bit. So he sends 1101. So now the guy on the very right shows two joins. So he knows that if he sends to G, he has to send to 0011. Because those are the 2 bits that he saw the join coming from.
Okay.
So that's the whole thing.
Got your point.
So there is no signaling, nothing like that. You have this magic fabric. So when he wants to send to G, he just sends those 2 bits because he stores the state on the edge. I saw 2 joins on those 2 bits.
So then, if let's say at the very right bottom device would send that, it would send basically 0111.
Well, no, because the 3 didn't send the join. Oh, you mean when he sends a join? Yes, correct. He will send 0111 as a join. But if he sends to G, he will also send to 0011 because those are the 2 guys that join. So that's how IGMP works. It looks like normal IGMP, works on top of BIER. But you see no extra labels, no extra protocols, no signaling. You have this magic fabric in the middle that does multicast when you push the right bits.
Okay, now from my understanding, let's say I am doing Unicast MPLS VPN as well as multicast VPN, okay, on the same network. For the Unicast VPN, I will still have LDP if I have LDP as a signaling protocol. For the Unicast part.
Well, you could push it on BIER and then the multicast guys won't because they say Unicast is special kinds of multicast. Because nothing prevents you from sending a BIER packet with a single bit set. You're welcome.
So what you are saying is important now, very important. You are saying even for the Unicast MPLS VPN, not only MVPN, let's use BIER.
I think it's, I mean, what we have works pretty well. But if you have BIER deployed and BIER works for you, and your PE is already a BIER address, who's going to stop you? I mean, who's going to stop you, frankly? I mean, of course, you have to think about resource reservation, right? Because now you cram the stuff onto a tree. And the tree means possibly congestion. So if you have something like RSVPTE that will spray you LSPs of a whole network, now you have to think in completely different terms. You have to think that BIER will give you this multicast tree that also does ECMP. So it's kind of has this...
You want that multi-point RSVPT to provide traffic reservation to BIER tree that provides transport to MVP.
Yeah. So there is something called BIER. I don't go there, right? So BIER does. So here's because you like this. It's this SR similarities, right? It does not provide you resource reservation.
Yeah.
Right?
You still need centralized entity that does it. There's no tenant network.
If you don't have RSVP anyway, LDP will not do that. So from that aspect,
don't forget targeted LDP. The largest success in networking. No, I'm joking. Okay. So BIER, however, so what we did, we very carefully put hooks into BIER. That BIER can either run on top of IGP computation, or it can decouple completely. So you could very well put into IGP some metric additional BIER information. We have the hooks and specify a distributed algorithm which has nothing to do with IGP, which can do really weird things. I give you a first example. You could specify an algorithm that understands how many subdomains you run on your network and have one subdomain computation avoid the other one to get these joint. You can do really, really weird things. Right now, the simplest way is you IGP shortest path routes. No resource reservation, just replicating fabric. But you can very well build multiple planes and run funky computation. You could run something, I don't know whether you're familiar with Steiner trees. Yeah. Which are really, really important for a lot of people pushing huge volume multicast, which have nothing to do with SPF, right? So you could run a subdomain and specify that the computation is Steiner. Now, BIER is nice because BIER could be also installed by a central controller. And we would have to go to the picture, like what does it take to BIER? You could actually, with PCE, push all the BIER state, the forwarding cables on the router without any signaling. That's forward packet chart. We made architecturally sure it is possible. So you could compute your Steiner tree centrally, or you can push it to the router and say everybody understands, just like we have Flex Algo. right? Way before FlexAlgo, we already had the stuff, maybe at the same time, whatever.
So,
And like, you specify which algorithm the nodes are running, so everybody could agree on running the Steiner.
so
And so you get this Steiner computation,
similar
which
to
is more complex than it sounds.
if we will do that resource reservation and use BIER just for that, we would need like PCEP type of protocol and extension for BIER.
You could run any kind of CSPF locally on devices.
Yes.
So imagine your optimization is not based on the metric, but on the lowest delay, on any other metrics that you have in a network. And this is kind of how FlexAlgo could be used with BIER. So you could optimize towards another set of constraints.
Sure, but if you are doing bandwidth reservation, what you will do?
No. So there's no reservation, there's a computation.
Yeah, exactly.
If you want to reserve something, you need to have full state of the network somewhere.
Yeah.
So there's no...
Yes. Then you need basically a connection setup which holds per connection reserved resources. You need some resource reservation. The BIER architecturally is completely agnostic towards that, but not provide anything. We were more concerned about the computation where you steer the traffic towards the network. Because multicast resource reservation is a really, really devilishly complex thing. Right?
Actually, that is very important. Even RSVP doesn't reserve for the multicast traffic, right?
RSVP point to multipoint tunnel is nothing else than a bunch of tunnels, right?
So, but RSVP is not reserving. Is it?
No, you could still do reservation per sub-tunnel.
Okay.
There's a number of objects in RSVP that allow you to do.
Okay.
But to answer your question, obviously there are BGPLF extensions for BIER, surprise, surprise, which could be used to signal BIER topological information to the controller, and controller can do any magic with it.
Yes, I was actually saying that, and I was trying to ask that for the controller, do we have any BIER extension or not? And you answered that. Okay.
BGPLS.
Yeah.
The same protocol.
Yeah, I mean, BGPLS and PCEP are pretty much the technologies you know, where you stuff all this kind of information in and drive it. So, all right, so we kind of walked a couple of things. So I also have something that explains how NVPN works, but that's kind of get a long discussion. Basically, BGP signaling stays the same. We have a new tunnel attribute, and within that is like which BIER subdomain you're running and what your BFR ID, that's about it. And otherwise, all the signaling, including the tracking and the PBits, everything stays the same.
There are other things like for even inside BIER, there are things that you can scale BIER networks. So BIER is for scalability, but there are also things that you can do like sets, areas, those kind of things for scaling even BIER networks. So it can really, really scale high. And if you are interested, probably you can find some other presentation for that. But for this one, let's talk, like there was many unique talks here about BIER, by the way, in our session. I want to talk about also the challenges. So, okay, so far, because usually what I say, whoever I talk with in my classes, etc., there is no single protocol that's always best. So, it's in a context, it might be best. In a very narrow down point of view, like scalability, if you are looking for, go for BIER, we can say, for specific networks. But you gave an example, Orhan, if you are dealing with the one group, two, three group, no, probably whatever you have today, you don't need to change. So this is understandable. Again, when we say this, there is no best, so there should be some problems, trade-offs about BIER. Let's talk about them.
Vendor independent in this case. So new silicon, none of existing silicon 4 or 5 years ago could do BIER. So it definitely requires hardware upgrades, which everybody did by now. We know there's interop between Juniper, Nokia, I assume Cisco as well, right?
Okay.
So new silicon is there.
So
number two, it's very different technology. So there's always cost and learning curve to get there. If this technology is not core to you, you know, there's still very large network running Roslyn, surprisingly, right? Why? Because it's not their core competence, and they know this stuff. So it's always a combination of how much money it's making for you, how important is this, What are you going to do going forward? There's a reason the first people who got really interested in BIER were financials, right?
Why?
Because they all use multicast. They all use multicast at huge scale.
Okay.
And there's some additional requirements for multicast, timing, some other stuff. So they were really the first driving company to get BIER done.
Fast reroute,
Now
etc.
to pass
also.
it to Tony.
Yeah. Let's listen from Tony as well.
Yes, well, so I answer you with a joke, with, you know, a very old multicast had Lenny Giuliano. When you look at BIER, he has been multicast 30 years, and his major gripe is that it does not solve, you know, multicast to the toaster. This thing will not scale to the planet. So Lenny's always saying that we solved the hunger problem in Beverly Hills, right?
Got
Like,
it.
we solved multicast for the core, like wonderful, right? Everybody drives a Rolls Royce, and now you solve the problem of, you know, of these people being hungry. Because ultimately, what you can address with this technology is something like 30,000, receivers. Now, if you're running a core that needs to run multicast, and I give you 30,000 PEs, and then I give you multiple subdomains, and I give you maybe 60,000, that is by all means a really, really massive scale. Because don't forget, the core doesn't have addressing, it's just the edges. So if you run 60,000 PEs, cool, BIER will give you this magic. But if you look at multicast to millions of devices, BIER is not for you. Right? Hence, Lenny saying, you know, it's solving hunger in Beverly Hills.
Okay.
Or to which my answer is, I'm perfectly fine with that. Beverly Hills is where the money is, right? So,
Two questions from there. First,
Yeah.
why you would need multicast for millions of receivers? Second, why BIER is not solving for millions of receivers?
Well, because it will not address a million devices, right? This is not realistic. Let's say you set this 256 bits, right? And you want to address a million things. Now imagine how many labels you already need. You're just running out of labels.
Fine, but in this case, yeah, 1 million for the label space, which is 20 bits normally we have. That's understandable. But what would be the use case for millions receiver? What would be the use case, do you think?
Well, no, that's the multicast guys, right? Like whatever they do, they want the millions of multicast nodes, and then they have application. It's all fine, right? But basically, what I'm seeing is this is basically a core technology, right? Where you need multicast on a massive scale, and I give you a course number, EVPN. You know what EVPN does with the bump. If you do Unicast, you know, Ingress Rep, and you flip on BIER, we were seeing customers number. Reduction 1 to 50. All of a sudden, your bump traffic is only 2 to 5% of what you had as volume before. BIER has other things that are extremely appealing. There are people selling businesses that rely on auctioning of streams.
But still, with EVPN also you can do ingress replication, or you can use multicast as a transport there.
Correct.
Yeah.
So when you flip on BIER, compared to Ingress Rep, all of a sudden you see this huge saving, right? But I should be talking more about the problem. So the scale that it doesn't go to millions and millions, that's what the multicast guys perceive as a problem. And it's the silicon, right? The silicon. If you want to drive to stop at speed, you need silicon. That went decently well. I think the biggest challenge for the multicast in total is the discussion whether multicast will survive, right? It is driven by a couple of niche applications, which are very high value, right? And there's a couple of interesting drivers coming in that tell me multicast will be still important. Uncompressed. Look at an uncompressed 8K stream. It is terrifying, the size of it. I think I was talking to someone about 8K, 10K uncompressed. It's 400 gig.
Yeah.
It's just massive amount of stuff. And believe me, there's enough multicast that must not be compressed by load. Right? There is interesting drivers where streams are being auctioned, high-value streams. Think about computer gaming streaming, where actually stations syndicate streams. which may last just for an hour, and you have an auction going of hundreds of people for the stream. And BIER will allow you very, very easily to provision who you send the stuff on to, which traditional multicast is very difficult. Imagine how many groups you have before they bootstrap the stuff. We're talking here like auctions that go down to like minutes, hours on a large scale. So all of a sudden, BIER allows you that, right? So there's those drivers. But when you look, for example, hyperscalers, they are Ingress wrapping the hell out of everything, right? So there's a tension between the high-value multicast and how much will it be generated, and can you really cope with Unicast?
That point was also interesting. Like you said, for the hyperscalers, they are doing a huge ingress replication because they are using EVPN, and then it's somehow...
No, hyperscalers are not using EVPN. Basically, their applications are all built to Ingress Rep.
Okay.
They just not deliver in multicast. They want really simple network substrate. And, you know, they think about networking differently in multiple ways, right? Which we see coming through, right? They think about networking devices as servers, right? Much more. You see them thinking of all the application complexity going to the edge, which I think is a good thing, right, on the server. Like overlays, everything starting on the server. Like, why the hell would you have networking device doing all this weird stuff that you cannot upgrade and muck around with, right? But they're, in a sense, also, I will now use the word carefully, pretty naive about what networking is, right? A lot of them see a network as a RAM chip, which basically means it's lossless and it has a constant delay. And we both know it's not the reality. That's not what the network is, right? So you see that when they're running massive bus systems, and they end up surprised that it doesn't behave like a memory system, right? The battle, there was a huge battle raging about 25 years ago whether the correct model to run distributed computation, because that's what we're all doing, they just do it at a huge scale and make a lot of money, is to do something called EVM, which is message-based synchronization, or whether you should run a distributed shared memory model. And lots of money and time by really bright people has been spent on distributed memory model, where the thing looks like one single huge block of memory. And that has been given up. And that's why we're running message-based synchronization. Call it Kafka, blah, blah, there's a million names, right? 0M2, whatever. But basically you run architecturally a messaging system. And the messaging system is an utterly different thing than the piece of memory, architecturally speaking, right? So I don't know how the battle will play out, because I do not think we can build a network on a large scale that behaves like a piece of memory, right? And that may swing the battle back to multicast and you already see it, machine learning is doing an enormous amount of replication. And Ingress replication creates a lot of very interesting problems, which multicast would solve. But multicast is a niche technology which is kind of very expensive, but then again, if the silicon becomes pervasive, then why the hell not use it, right?
So very few people run multi-custom data centers to use network replication, for example, for bump traffic, right? Why? Because PIM is troublesome. People are actually afraid of it, and there's still a lot of bugs, let's be honest, right? So if, as Tony is saying, we can create plug-and-play technology that just does it, there's absolutely no reason to do any Ingress replication.
Okay, now a question is then, if I solve the hardware silicon issue, do you think BIER would be more deployed?
Well, look, if the stuff is abundant and it's cheap and it's easy to consume, believe me, people will buy and use a lot of it. That's how things work. Unless there's something more convenient and even cheaper and even more abundant. And the moment the stuff becomes complex or scarce, people find a substitute. It's just pure economics. That there's nothing to do with
For the hardware support, basically, Silicon needs to understand what is Bitmask and how the forwarding works with the BIER, etc., right?
Right. So, I mean, we can talk like how it goes to our routers. Actually, the logic is very simple in a way, but it's a very cool because you can implement it in many different ways. You can optimize for speed, for how much memory you consume on the chip. So it's actually much more subtle than it looks. The logic is fairly simple. The problem is that none of the normal IP lookup logic blocks work. You cannot, basically, you cannot use what we will call this thing, what the thing that's everybody using, not hashes.
Destination-based IP lookup doesn't work for that.
No, it's not an IP lookup. I mean, it's not very amenable to the traditional, what you call this thing. You have it on all the FPGAs to look up.
Hash tables?
Like Mac lookup. Yeah, right. So basically, it's not amenable to hash tables. Well, unless you're really, really smart and you figure some interesting properties of it. But it's basically a new logic block. So you really have to put the gates on for a new logic block. Right? So that's the complexity. The logic block is not complex. It's very regular. It's not a lot of complicated stuff, but it's kind of a new thing that you have to throw on your silicon if you want to do it at speed. Right?
Okay.
So I can walk you through how it works.
Being in Silicon Valley, you definitely see proliferation of smart NICs. Fungible, Pensanda, Intel with Barefoot. Everybody is pushing exactly the same thing.
And that's an interesting observation. That's an interesting observation Jeff makes because it actually is very easy to do on an NPU. For an NPU, it's a fairly trivial thing to do.
Yeah.
So Jeff,
for the pipeline.
Jeff, do you think that we will see soon, or did we started seeing silicon which supports BIER soon?
On the part, you can program it today in smart NICs. You could definitely program it in Metronome. You can definitely program in the latest Mellanox. I assume you could easily program it in Barefoot.
Yeah.
And
one program for BIER would take 3-4 days to program.
Okay, question: do those Cisco, Juniper, big vendors, do they use this silicon in their device?
We use everything under the sun pretty much. Well, you know, like we have Broadcom boxes, we have our silicon boxes. I lost, count how many different silicon things that we have.
So actually, I was talking about hot silicon, the smart NICs actually.
Right. So smart NICs
can do BIER without.
Yeah, because like I said, a network programming unit, like a network processor, it's very easy to implement. It is more the pipeline chips. And that's where the problem comes, right? All the like Tridents, Tomahawks, the cheapest stuff is all pipeline because that's how you build it at low cost. So you need the full silicon RAM, right? Even the Jericho. Sorry,
Jericho 2 does BIER.
Yes.
So actually, we both were in Israel discussing it with Broadcom.
So, but again, Juniper, it seems supporting those silicons. Do you know whether Cisco, especially those famous boxes, supports, or will they support those silicon?
I cannot speak for my, estimable competitor. Okay, it would be bad form and it would not be wise.
But today, as we know, today they don't. Because I don't know. That's why I'm asking to you guys. Today they don't support, I think, right?
So just deriving NCS 5500 is Jericho 2. There are more boxes with the Jericho 2. Silicon-wise, they do support BIER because we know Jericho 2 does. We know that Nokia supports BIER today on FP4. Tony can tell you that Juniper does support BIER. So you're pretty much at 90% of the market.
Yeah, it is there, guys. We should start seeing some announcements. I mean, some people, at least in the network operating groups, those kind of meetings, maybe, yeah, we deployed BIER, etc. I remember some public presentations. The guys, I think from Australia, the mobile operator, they were thinking a couple years ago, but after that, I didn't see they deployed or not. Let's see. I mean, because for this technology to be, to be more and more attractive by the network engineers also, right? Hopefully now they will get some idea. If until this moment they watched this video, it's great, of course. But even at the first 15-20 minutes, we gave them an idea. So probably when they see more deployments, they will start watching these videos again and again. That's also another hack.
Yeah. So I'm always very, pretty tight. I can tell you we gave it to a lot of people. And if you want a Junos box with BIER running, talk to us, not a big deal. Including VMX. So, we run the stuff on VMX as well. I mean, why the stuff is not widely screamed about, don't forget, this is right now a core technology. Those people are guarded because those things have huge competitive implications. Who deploys what in the core? Don't forget, right? And there is, of course, an enormous amount of religious, like and dislike.
So
like in PLS.
basically what you are saying, since there might be some competitive advantage deploying BIER, they will not immediately go and say we deployed this and we got lots of benefits, etc.
Well, just think what happens if I can offer you a core, I'm selling you NVPN at a fraction of the cost of an L3 VPN, right? Yes, these kind of things can shift complete competitive landscape. So people are not too open talking about this kind of stuff because there's no upside.
By the way,
you talk about when you have a service offering.
Definitely, I agree with you. And in fact, I think it was 2 years back while I was writing my service provider network design and architecture book, I was talking with some guy. And he was the lead architect in one of the very large mobile operator. Let me just say that without giving the name. And I know what he told me. This conversation happened 2 years ago, 1.5 years ago. And then he told me they went to United States to talk with some vendors about BIER and how they can deploy, what would be the advantage and all those stuff from their country to the United States to talk about the BIER. I remember that one as well. But maybe they deployed today, I am not sure. Maybe some part of their network they deployed, I'm not sure. But this discussion was 1.5 years before, and when I talked, they already went and they were doing some investigation. Those days actually triggered me. I should look at this BIER, what's happening more and more, and today we are here and talking about these details. Yeah.
Yes, I mean, you also, with these large core networks, I mean, don't forget the deprecation cycles, rolling cycles. Those are 7, 10, 15-year cycles. So those things don't just show up, right? You'll get some small thing, the stuff runs for a year or two, some other stuff, you have to add some knobs, then you have to talk about your product roadmaps, and you roll some boxes in, other parts don't, and the stuff kind of creeps into you. No one just flipped MPLS overnight on, right? It took 10 years for a lot of people to roll the technology out. I mean, those cores, you definitely don't want to melt them. This ends a lot of careers, right? So even if the technology promises to be, the Goldilocks and solve all the world's problems and humanities and everything, it still goes slowly.
That's true. And in fact, they were another operator was they want to deploy TILFA, as you know, segment routings, loop free alternate, topology independent. So, but they didn't find it very mature. This is a little bit also old discussion, like 2-3 years old. And when I listened them, they said the maturity, the interoperability between our vendors in our network is the most key thing for us. Forget about the cost, forget about other things like which routing protocol, but from the technology, what we are looking for, is it standard because we have multiple vendors, and is it mature? So if we deploy today, will there be any bugs so that this can melt down the network? Now you are saying that. So maybe a couple last questions. So already it's very long discussion, but very useful as well. So BIER, do you think, guys, BIER at the moment is mature enough to deploy at least in the core networks?
Yeah, absolutely. Yeah. I mean, that has been around for a bit. I mean, they were talking since about a year or so. I mean, we ran the stuff at scale. We know how it behaves. That's the technology is mature enough. I mean, I'm speaking, of course, as a vendor, right? But in terms of like what people rolled in silicon, how many people looked at it, right? And whether it really gives you the benefits, it's there, yeah.
Almost, not actually, almost every question of mine so far was personally to Tony. But now, if I, of course, you don't have to answer. So now this time for your Juniper hat, does Juniper have any BIER customer? Any?
And I can answer you that. I tell you, we gave it to a lot of people. Lots of stuff has been played. Okay, stuff has been put and played effectively. You know, we have it on lots of boxes. What I can tell you, I mean, we don't bet the shop on it, right? We still have a lot of other stuff. I mean, we're forced to build a lot of different technologies. This is one of the technologies we build. You can get your hands on. So please talk to us. Will it hold up? Yes, it will hold up.
So
okay?
Sure.
Because we have had it for a while, right? And that's what I can tell you. And then people take it in the labs and they take it from there in different places. We have a lot of different conversations. But look, I mean, it's not like team will be switched off overnight, right?
Mm-hmm.
You know, and it has to fit in a huge architectural landscape and product roadmaps and so on. So there's a lot of discussion around that whole thing, right? And there's multiple competing technology. People talk to us. So the discussions are never that simple, right? This is like those things are like little pieces in a puzzle. And the customer puts his thing together. And like you said, the interoperability is the most important thing to me. We have large customers who says, I couldn't care squat about interoperability. I am running 2 planes which are strictly vendor disjoint. I don't want you guys to talk to each other. What I want each of you guys to be as bug-free as possible. And if you have a bug, then it's a bug you can test because it's on your own devices. And if you bug enough, I just switch you off and run over the other vendor. So I have absolutely no interest whether you interrupt or not. Do whatever you want. Just make sure that my plane in your vendor plane works. So there's really different, and there, for example, it's much easier to push something that you cooked up yourself.
Yeah,
those like, well, it's RFC, like who cares? It works better.
People.
And then a completely different side of the spectrum is application-based BIER. So as you know, there's a number, especially financial companies, who do multicast cost to cost. And they've built some development. I don't think there are any public announcements. People were migrating from a GMP MLD directly to BIER from the host.
Interesting.
And think about it. You don't require any support from network in this case. So imagine you run on top of public cloud. There's no multicast, it's all IP. So if you can build your overlay over public cloud using BIER, suddenly you got very efficient replication with 0 changes. So it's very interesting spectrum. Not well understood, not well discussed, but there's definitely some stuff going on there.
It's a very weird idea. You are selling multicast as a service over cloud.
Yeah.
So you use BIER as a control protocol to basically have all your synchronization, basic replication points you are buying on the cloud being synchronized, basically having a control plane, and then you run BIER forwarding to replicate.
Interesting things happening.
And it would work actually.
And it seems to be a market for it. I mean, I only know a limited, amount about the whole thing, but I was also baffled with the idea. Why the hell would you run BIER in the cloud as overlay? Because you can sell multicast as a service.
Okay.
And it's really needed. AWS announced they finally support some degree of multicast with stacking joints and everything. So it looks very rudimentary, but it is multicast, native multicast in the cloud. Imagine you could do it with BIER. It's completely different order of magnitude, scale, how you do it at application layer. Just think about accessibility.
Yeah, so within a data center, we have to switch, PIM, or you start to think about something like a BIER overlay, which is kind of crazy, right? It's significantly simpler. And yeah, I mean, Amazon was for a year resisting. They have been finally beaten to pulp by customers. Just too many things weren't working.
Okay. So guys, I think we discussed many things about not only BIER, as I guessed in the beginning of the discussion, but we touched many other stuff as well for the scalability. Even we talked about BIER could be used for the Unicast MPLS VPN service, etc. This, I mean, in theory, why not? But of course, even the discussion would be another 1.5 hours just if we will talk about that. So let's keep this video as a introduction to BIER and why BIER and little bit comparison. What's that?
Can I share a screen for a second?
Sure, just a
Yeah.
second, of course. Let me make you presenter at this time. I just did. You can share.
So this is the first BIER dinner, officially. This is the first multi-vendor discussion about BIER.
Okay, let's see. Jeff is there. Tony is there as well. both are there. Yeah,
So,
actually there are other.
And Galgana who was driving BIER at Nokia Alcatel. This is Thiago who was driving BIER at Huawei. This is Ice and Greg who were driving BIER at Cisco. And this is Jeffrey from Juniper who actually did all the coding. And AC and all other HTTP guys. So, full picture.
Where was this one?
It looks like Singapore something. I'm not sure.
I couldn't remember. So you know there was also a special beer being brewed after it became RFC. You have to talk to Greg Shepp. He's the guy in the Hawaii shirt. The guy never dresses well. He's my co-chair. So his son actually has a brewery. So there's a special beer that has been brewed. I don't know where my bottle is. Somewhere, in a drawer.
So
I have a bottle of this beer on my table, actually.
We still see your screen, by the way. Okay. So guys, let me summarize very fast, and then let's close with your couple last words. This video. Basically, we discussed why BIER, what is BIER, and some advantages of BIER. Actually, we discussed, especially when it comes to scalable, very large core networks. BIER makes sense, we said, and also some other use cases of BIER we talked about with the MVPN, etc., how it could be used. It's basically providing us scalable, simple transport mechanism, but also we discussed the challenges like, silicon support is one thing, and not each and every, at the moment, device supports it. Maybe some hardware upgrade is necessary, but when you do that anyway, eventually 5, 7, maybe 10 years, change life cycle is coming, and then when you replace with the newer hardware, most probably those hardwares will support anyway, and BIER might be one of those another tools in your tool belt, so you can use. This video I wanted to keep as an introduction, but if we see the really interesting comments, if you like this, like the video as well, and put your comment there. I will share the Jeff's and Tony's LinkedIn profile as well in the video, so you can talk to them, especially if you are looking to discuss maybe for your network deployment BIER. You can reach out to Tony, so he's a fellow in Juniper, and then he can help you for your design, etc. So let's keep this one as an introduction, but as I told you, if there is an interest, put your comment, share your comment, feedback with us, so we can come up with and talk with interesting stuff like we just touched upon, but we didn't go into detail. We can, so let's see your interest. Okay guys, what you would say as last couple words? Maybe let's close this video. Any of you?
Oh, from my side?
Yep.
BIER is a good idea, and I'm a firm believer in the terror of the better idea. There's this philosophical concept that the better ideas win at the end. It's a terror of the better idea. Unfortunately, the world works the way that people would try everything which is the worst idea first before they end up with the best idea. So this thing is rolling, its time will come. That's about as, that's why I got involved in the whole thing when I looked at the stuff. Right? It is an excellent idea how basically multicast should have been done from day one, I think, in terms of technology, even independent of IP. Okay.
We will probably.
Thank you for having me. A pleasure.
Thank you. It's always great.
I just see stars coming together. The increase in traffic with COVID, people working from home, 5G is coming. So all we see is more and more traffic, and a lot of it is actually replicated, Ingress replicated, right? So timing is right.
Timing is right, Jeff says. Lots of use cases, like maybe in the cloud. Tony and Jeff said as a multicast as a service, as one idea might be, and a large-scale multicast network could be deployed in the cloud. Also important, he just touched that 5G is coming, more traffic is always in the network, so 5G is promising also more traffic, right? So it's right time, because ingress replication more and more we are seeing. There are, so far we did couple sessions, if you remember, especially we touched on 5G, the like BIER now, BIER and 5G, and we talked also with Dino, Lisp and 5G use cases. I think at some point we talk very high level 5G and these protocols interaction, like BIER in 5G use case, why it would be, etc. Tony can talk about it us in the future video, and maybe also a little bit we can touch more on the Lisp and 5G. So those kind of things, these are future technologies, and future is here now. So okay guys, thanks for joining again. Always Jeff and Tony, very
I didn't think that BIER is the perfect technology for Zoom video conferencing, but maybe this will make it. Okay. Thank you a lot, Orhan.
Mind-blowing discussion, another discussion. Thanks a lot, guys. They say also thank you. As I told you last time, let me remind you, if you're really interested, if you found this video useful, if you liked it, like the video, share your comments, feedback, so we can continue with the discussion of BIER. Okay, thank you.